This video is going to cover how to maximize some function subject to certain constraints using the simplex method. And so we have seen an example similar to this, and we maximized using the method of corners, which is a graphing technique that we can use. And that works great given that we have two variables. But when we have more than two variables, we really need another method to help us handle that. And so that is when the simplex method comes into play. So for this example, just to keep it a little simpler, I'm going to only have inequalities with two variables involved. But know that for this example, you could use the simplex method, it's fine, or you could use the method of corners. Either one would work here. Again, if we had another set of criteria, for example, we had something like x plus 5y plus z is less than or equal to 30, and 5x minus 10y minus z, okay, and etc. This is an example where you would really want to use the simplex method rather than the method of corners, because it's not really feasible to graph these and figure out what's going on. And so that would be an example where you would definitely want to use the simplex method. So for this one, let's walk through how you would use the simplex method to solve. So the first thing is you want to be able to set up a matrix for all of your information. So that includes all of the inequalities that you're given as constraints, as well as the function that you're trying to maximize. The issue is you really don't want to put inequalities into a matrix, and so we have to have a way to kind of transform these into equations. If we simply look at the first equation, x plus 5y is less than or equal to 25, the less than or equal to means that the left side is smaller than the right side, or it could be equal, okay? So that means if it's less than, if the left side is less than 25, we could add some amount to where we could make them equal, right? So we could say, let's say we added some amount s. That would now make these two be equal instead of the left-hand side being less than. An example using numbers, let's say I had 3 is less than 5. We could agree that that's true, right? I could change this into an equation by saying, hey, I'm going to add some variable to 3 so that now it's equal to 5. I'm going to change that to an equation. And we would see here that in this example, S1 would be 2, right? So that one's clear. But if we have other variables involved, we don't know exactly what we need to add, but we know that we can add something to the left-hand side to get the right-hand side. So basically this variable is picking up the slack. That's what's keeping these two sides from being equivalent. And so that's why these are going to be called slack variables. So the first inequality, I can make an equation by adding this S1 to it, and that's going to be the slack variable for that first inequality. And I can do something similar for the second inequality. The third and the fourth inequalities, those are commonly seen. They're just saying that your x and your y variables are non-negative, and so we don't really have to include those in the tableau, or in the matrix, I should say at this point. All right, so the first inequality, we're going to make that into an equation by adding in a slack variable. I'm going to call it S1, and that's just because it's the first equation. And then the second equation is going to have some slack variable. Now, I might not add the same thing to that equation, so it's going to be a different slack variable. So I'm going to call it S sub 2. So S sub 1, The subscript 1 is because it's associated with the first inequality. S sub 2 is a 2 because it's associated with the second inequality. But notice that those are not necessarily the same number. Okay, so now what I want to do is use these two equations that I've come up with and start writing a matrix. Remember, when you're writing a matrix, each column represents a variable. So you will see that I have the variables x and y. But I've also added in these slack variables. So S1 is a variable and S2 is also a variable. Now I also want to include my function that I'm trying to maximize. So in my matrix, I'm including this first inequality written as an equation with a slack variable, the second inequality written as an equation with a slack variable, and the function that I'm trying to maximize. Okay. So I'm going to have 3 rows in this case. So each inequality is going to get a row aside from the non-negative inequalities, and the function I'm trying to maximize is going to get a row. So in this case, I'm going to have 3 rows. The next thing you want to realize is that you always want to have your solution or your constant on the very far right of your matrix. If I look at the function I'm trying to maximize, okay, I don't have it set equal to a constant. So I've got p equals 3x plus 2y. There is no constant there. That means I want to move everything to the same side and set it equal to 0. I'm going to move everything to the same side as the p, so I can keep p positive. So that would be negative 3x, negative 2y, plus p equals 0. So I moved the 3x by subtracting, and I moved the 2y by subtracting, so those 0 out. And now I have this equation, negative 3x minus 2y plus p equals 0. Okay, so I have this other variable, p. So in this equation, you can see that I have variables x, y, and p. I don't know what p is. So that's another variable that I have to define at the top. So it gets a column. Okay, and then last is going to be my constants. Okay, so my rows are, in your examples, they'll be called S1. So you can say that that's the equation associated with the first slack variable. S2, that's the equation associated with the second slack variable. And then P. So that's the equation associated with whatever you're trying to find. Okay. Okay, so now I just need to fill everything in. So my first row is going to be made up of the equation from the first inequality. So let me just kind of write it next to it. So x plus 5y plus s1 is equal to 25. So let's look and see what I have. I have an x, it's 1x, so a 1 is going to go under the x column. I have a y, so I'm going to have 5 under the y column. I do have the s1, that's the slack variable here, so I'm going to have a 1 here. There's no s sub 2 in this, so I'm going to have 0. There's no p in this, so that's going to be a 0. And then the constant is 25. So if that variable does not appear in that equation, it's just a 0. All right, the second row is going to come from the equation associated with the second slack variable. So that would be the 4x plus 2y plus s sub 2 is equal to 28. So let's see what we get from that. We have an x, so 4 is going to go in the x column. We have a y, we have 2y, so 2 is going to go in the y column. Slack variable 1 does not appear here, so that's a 0. We have slack variable 2, so that's a 1. P does not appear in this equation, so that's a 0. And then 28 is our constant. And then the last row comes from the function we're trying to maximize. And remember, we rewrote that as negative 3x minus 2y plus p is equal to 0. So we have an x, that's a negative 3x. So we put negative 3 in the x column. We have the negative 2y, so negative 2 goes in the y column. No slack 1, so 0. No slack 2, 0. We do have the p here, 1p, so it's a 1. And then the constant is 0. Okay, so you're often going to see a line here. And so the vertical line separates the variables from the constant. The horizontal line separates your constraints from the function that you're trying to maximize. So that's what the purpose of the lines are. This matrix that we have now set up is called your initial simplex tableau. So let me write that out for you. This is your initial simplex tableau. So you have used the constraints and the maximization function to create this matrix that's called the initial simplex tableau. And now we're going to use a simplex method to try to maximize this. Okay. Before I move on, I just want to point out something. Notice that if you just look at the matrix made up by your slack variables and the variable p, which comes from the maximization function, notice that we have 1s along the main diagonal and 0s everywhere else. So this is an identity matrix. That is not a coincidence. That should happen when you're creating these. So kind of look for that. Okay, so let's go through the steps that we'll need to use to solve this problem using the simplex method. So the first thing you want to do is select a pivot column. Select a pivot column. You're going to do that by looking at the bottom row and figuring out what is the smallest number that you see. So that means it's the largest negative number. So the smallest number, or another way to look at it, the largest negative number, is negative 3. So this is going to be your pivot column. Again, that's because that's the largest negative number in the bottom row. And you're always looking at the bottom row when you're trying to decide your pivot column. Now that you have your pivot column, this column, you're going to try to find your pivot row. So your pivot row is found by using the test ratios from each row. The test ratios are made up from dividing your constant by your pivot column. So 25, that's my constant, divided by 1. And that would just be 25. And then you're going to do the same thing for the next row. So 28 divided by 4. 28 divided by 4 is 7. To identify your pivot row, you're going to find the smallest number that appears. So 25 are the smallest test ratio. So test ratio. So the top one was 25. The second one was 7. 7 is smaller. So the second row is going to be your pivot row. And what you're interested in is what number is in the position that your pivot column and your pivot row meet. So if this is your pivot row, you can see that the 4 is in that position, right? So the 4 is called your pivot. Okay. The pivot is important because what you're going to do is you're going to make the rest of your column zeros. So you're going to keep the pivot the same, and you're going to zero out what's above and below the pivot. Okay. So if I do that, I want the 1 above that 4 to be a 0, and I want the negative 3 below that 4 to be a 0. So let's see how I can do that. This is similar to when we found the reduced row echelon form, but instead of having a 1 in our pivot position, we have whatever number we get. So in order to save space, I'm going to rewrite this initial tableau smaller, and then we'll start from there. All right, so here is our initial simplex tableau, and we're going to zero out the 1 first. So remember that we decided that 4 is our pivot, and so we're going to zero out above and below that. So we're going to zero out the 1. So how could I do that? So I want to multiply the row that has the pivot and then add that to the row above it to zero that 1 out. So basically I want my pivot to be a -1. That would cancel out the 1 above it, right? So if I multiply row 2 by 1/4, oops. In other words, divide by 4, right? If I divide by 4, I get 1, and I want it to be a -1. So I divide by -4. Another way to say that is you multiply by -1/4. So multiply row 2 by -1/4, add that to row 1, and replace row 1. So let's see what we get when we do that. So row 2 stays the same. -1/4 times 4 is -1 plus 1 is 0. 2 times -1/4, so I'm just going across the row. 2 times -1/4 is -1/2, and then I add that to 5, so that would be 9/2. Okay, -1/4 times 0 is 0, plus the 1 is 1. -1/4 times 1 is -1/4, plus the 0, -1/4. -1/4 times 0 is 0, plus 0 is still 0. And then -1/4 times 28 is -7, and -7 plus 25 is 18. All right, so that's how I get my top row. So my 0 now is where I want it to be. And I'm going to do something similar with the third row. So in order to zero out this -3, I am going to have to first make that 4 be a 1. So that's like dividing by 4. And then I'm going to multiply by 3. So divide by your pivot and multiply by the opposite of whatever you're trying to zero out. So multiply 3/4 times row 2, add it to row 3, and replace row 3. So 3/4 times 4 is 3, plus the -3 is 0. 3/4 times 2 is 6/4, which is 3/2. Minus 2 is -1/2. 3/4 times 0 is 0, plus 0 is still 0. 3/4 times 1 is 3/4, plus 0 is 3/4. 3/4 times 0 is 0, plus 1 is 1. And then 3/4 times 28 is 21, plus 0 is 21. All right, so now I have gotten my first column done. And now I'm going to look and see if there is any other negative number in that bottom row. Because if so, I can do the same thing I just did in order to see what we could do to maximize the other variable. So we're going to see that -1/2 in the bottom is still negative. So this is now going to be my new pivot column. And again, it's because I still have a negative on the bottom. So I want to change that. So there's my pivot column. Now I have to figure out my pivot row. And so to remember to find the pivot row, you divide the constant by the element in that row. So 18 divided by 9/2, and that would be 4. And then we have 28 divided by 2, and that would be 14. And so you pick your row based on the lowest of your test ratios. So 4 is smaller than 14. That means that 9/2 is going to be my pivot. So here is my new pivot. So now what I want to do is zero out everything else in that column. So the 9/2 is going to stay, and then I'm going to zero out the 2 under it and the -1/2 under it. So let's see what we can do there. So in this case, if I want to zero out the 2, so I'm going to try to zero out the 2. I want to multiply the first row by the reciprocal. So I'm going to do 2/2 times row 1. That's going to give me a 1. But then I need to multiply by the opposite of whatever's there. So multiply by -2. So if I'm multiplying by the reciprocal and I'm multiplying by -2, I'm really multiplying by -4/9. So I want to do -4/9. So -4/9 times row 1 plus row 2, and that's going to become my new row 2. Okay, so let's see. My first row is not going to change, so I'm going to rewrite that. Okay, let's see, row 2. I'm going to have -4/9 times row 1, so -4/9 times 0 plus 4, so that will still be 4. Okay, -4/9 times 9/2, that's going to be -2, and -2 plus 2 is 0. -4/9 times 1 is -4/9, plus 0 is -4/9. -4/9 times -1/4, that's going to be a positive 1/9. And a positive 1/9 plus 1 is going to be a positive 10/9. -4/9 times 0 is 0, plus 0, still 0. And then -4/9 times 18, that's going to be a -8, plus 28 would be 20. Okay, and now I'm going to do something similar for the bottom row. I want to zero out the -1/2. And so first, I've got to think about making that 9/2 a 1. So to do that, I would multiply by 2/9. And then I really want it to be the opposite of -1/2, which means I want it to be a positive 1/2. So I'm going to multiply by a positive 1/2. So that means in reality, I'm just multiplying by 1/9. So I'm going to do 1/9 times row 1 plus row 3, and then replace row 3. Remember, you're multiplying by something. You're multiplying row 1 by something so that it will zero out that -1/2. All right, so let's see what I get. 0 times 1/9 is 0, plus 0, still 0. 9/2 times 1/9, that would be 1/2, and 1/2 plus -1/2 is 0. 1/9 times 1 is 1/9, plus 0 is 1/9. 1/9 times a -1/4 will be a -1/36. So a -1/36 plus 3/4, that will end up getting me 13/18. Okay, And then I have 0 times 1/9 is 0, plus the 1 is 1. And then 18 times 1/9 is 2, plus the 21 is 23. Okay, notice that I now have no negatives in the bottom row. That means that I am done with all the changes that I need to make. So at this point, we want to focus on what's called an active variable. And so that is going to include the variables with columns where we have exactly one non-zero entry. And so if you look in the first column, we have one non-zero entry. That's a 4. In the second column, we have one non-zero entry, and that's the 9/2. In the third column, we have multiple numbers there. Fourth column, multiple numbers. In the fifth column, you'll see that we have one non-zero entry, but it's actually in the bottom row. Okay. So let's just see what we have here. Remember that each column represented a variable. So from the first row, we have the following. 0x, we have 9/2 y plus 1 s1 minus 1/4 s of 2, 0p equals 18. That's what we get from our matrix, that first row. The second row, we have 4x, 0y, negative 4/9 s1 plus 10/9 s of 2 plus 0p is equal to 20. And then from the last row, we have 1/9 s of 1 plus 13/18 s of 2 plus 1p is equal to 23. All right, so now what you need to realize is that we really don't care about our slack variables. So any slack variable that we see, we're just going to assign it a value of 0. So if we assign a slack variable 0, that's going to eliminate that from our equation. Okay, that's super nice. It's going to have equations that are way better to deal with. So let's see what happens when we ignore or zero out our slack variables. The first equation we get is 9/2 y is equal to 18. We can solve that easily, right? Our next equation is 4x equals 20. Well, that's even easier to solve. Our final equation gives us p equals 23. So from here, we can see that p is 23. Originally, we were asked to maximize p equals 3x plus 2y. So this is it. Maximized, the maximum occurs at p equals 23. We can find the x and the y values where that happens by solving the equations that we just found there. So 9/2 y is equal to 18. We would simply multiply by 2/9, and we would find that y is equal to 4. 4x equals 20, we could solve by simply dividing by 4, and we'll see that x equals 5. So the maximum occurs at p equals 23 when x is 5 and y is 4.